So we're starting trigonometry. I'm just actually going to go through a little activity that I would be doing with you live just to kind of show you how trigonometry works. So it's a big word, but it's a simple concept. It's based on right triangles and similarity, which are the past 2 units that we've done. So first part about trigonometry, one of the most important parts is actually being able to identify your parts when you talk about a reference angle. So you have your hypotenuse, which is your longest side. The hypotenuse is still a hypotenuse. It's always in the same place. It's always the longest side and opposite the right angle. And then you have two other concepts. You have your opposite leg and your adjacent leg. And those actually change depending on what your angle you're talking about. So for this triangle right here, if this is called my reference angle, if I'm talking about this angle, well, this is definitely still going to be my hypotenuse. In this case, my opposite side is the side that does not form the angle, and then my adjacent side is the leg that forms my angle, the non-hypotenuse, the leg that forms my angle. If I go over here with this triangle right here, my hypotenuse is still my hypotenuse, but in this case, AB is my opposite and BC is my adjacent. So it depends on your angle which side's going to be the opposite and which side's going to be the adjacent. It's not a designated thing. So here it says determine the correct side based on the reference angle. So if I'm talking about reference angle R, this would be my opposite, this would be my hypotenuse, and this would be my adjacent. So my opposite side would be GT, my adjacent side would be GR or RG, and my hypotenuse, of course, is RT or TR. So just to give you an idea. For this one here, if my reference angle is M, this is still my hypotenuse, it doesn't matter. This is my opposite, and this is my adjacent. So my opposite side is GH, my adjacent side is GM, and my hypotenuse is HM. And last one is if my reference angle is C, okay, this is still my hypotenuse, this is still my opposite side, this is my adjacent side. So my opposite side is going to be AB or BA. My adjacent side is going to be BC or CB, and my hypotenuse is AC. So now we're going to get into a little activity that I would normally do in class. So basically, I'd have everyone in class draw a right triangle with a 40-degree angle, and I'd have you measure the sides. I recreated this scenario. So Octavia, Akadiva and Regina measure the sides of 2 different right triangles with 40-degree angle and compare the ratios of the sides. So the first one, the opposite side, so for this right here, DE is going to be the opposite, AE is the adjacent, and AD is the hypotenuse. For the other triangle, FG is the opposite, BG is the adjacent, and BF is the hypotenuse. And so they're going to compare, so they're comparing the ratios of the sides. So the first one, the opposite side, was 24, and the hypotenuse was 38. 24 divided by 38 is 0.63157 or 58. Okay, so it's that decimal. The adjacent to the hypotenuse, the adjacent side was 29 over 38, which is 0.7632. And the last one is opposite over adjacent, so that's going to be 24 over 29, which is going to be 0.8276. Okay. For Regina, opposite over hypotenuse, her opposite side was 37, the hypotenuse was 58, which is 0.6379. Adjacent over hypotenuse is 44 over 58, which is 0.7586. And opposite over adjacent, that's 37 over 44, is 0.8409. Okay, so the thing that you notice is these ratios are actually pretty close. So you have 0.3158, 0.6379, 0.76, 0.75, 0.82, and 0.84. So if we were in class, I would have you find the averages of all of these. So 0.631 plus 0.6379 divided by 2. So the average would be 0.63474. 0.6347. And the ratio to the adjacent over the hypotenuse, so 0.7632 plus 0.7586 would be 0.7609. And the last one is 0.8276 plus 0.8409. Divide that by 2, 0.8342, or 0.8343. Okay, so that's just for measuring the sides. Is if basically what I'm saying is that if I have a right triangle of a 40 degree angle, if I divide the opposite side by the hypotenuse, I should get this number right here. Doesn't matter how big or small it is, I should get close to that number. If I divide the adjacent by the hypotenuse, I should get around this number, and if I divide the opposite side by the adjacent, I should get this number. And that's essentially what trig is. It's just the ratios of the sides. Doesn't matter how big or small, they're actually constant measurements. So I look here, and so in the first column, so I have what's called a trig table. This is old school, but I think it's always a good visual. So I look for 0.6347 in my trig table here, and so I get really close. So 0.6347 would be right between 39 and 40 here. Okay, I look for, in the second column, I look for 0.7609. So something close to 0.7609. And 0.7609 would be kind of just in between here, close to 40, a little bit more than 40. The other one would be a little less than 40. And here, if I divide my opposite by my adjacent, so 0.8343, so I look in the third column, and 0.8343 is right around here. And so what these values are here in this trigonometric table is these actually tell you what you should get if you divide those sides, no matter how big or small the triangle is. So for instance, if I have a right triangle with a 33 degree angle, if I divide the opposite side by the hypotenuse, I should get 0.5446. And knowing that is very helpful, because that helps you solve for sides, it helps you solve for angles. If I divide the adjacent side by the hypotenuse, I should get 0.8387. I should get that number. And if I divide the opposite side by the adjacent side, I should get about 0.6494. And this is called a trigonometric table. This actually tells you the values that you should get. Okay, those three ratios that we started with, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, those are your trig values. So the first one, the sine ratio, is designated, the definition is it's the ratio of the opposite side to the hypotenuse in a right triangle. Okay, the cosine ratio is actually the ratio of the adjacent side to the hypotenuse of a right triangle. The tangent ratio is the ratio of the opposite to the adjacent side. And we have something, and it's always very funny to me because sometimes your parents remember some things about math, but this is usually something, if your parents took geometry, that they do remember, is we have a way of remembering this. So the sine ratio opposite of over a hypotenuse, we remember that as so. Cosine ratio, ka. Cosine is adjacent over hypotenuse, and tangent ratio, tangent is opposite over adjacent, toa. And so one way to remember is so, ka, toa. SOHCAHTOA toa is a way to remember what ratio, what trig ratio goes with what. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The next thing we're going to go through is finding the sine, cosine, and tangent. So this right here says find the sine of 67 degrees. So the sine of 67 degrees, what this is asking you is for any right triangle with a 67-degree angle, what should, if I divide the opposite side by the hypotenuse, what number should I get each time? And there's two ways of doing this. One way is you can actually go up to your trig table. So I can go to 67. So I look for 67 and I look in the first column because that's my sine column, and I have 0.9205. And so I write that down. So this is going to be 0.9275. And we usually round to 4 decimal places. There is another way to do this, which I'll show you right here. So in a calculator, I'm going to use a Desmo Scientific calculator. If you have your own calculator, that's going to be a little bit of a different story because you need to make sure that you get the same value as I do. So you should kind of practice this as I go along. So I'm going to press sine 67. Okay, and if I put sine 67 in, what you should get, if you put this in your calculator, you should get 0.9205. If you don't get 0.9205, you need to talk to me so I can fix your calculator that's in the right setting. Because there are actually two ways to measure angles. You have degrees, but it also could be in radians. So if you're getting, when you put sine of 67, if you're getting negative 0.8555, that's because your calculator is in the wrong mode and needs to be switched. And I would tell you here how to do it, but it depends on the calculator. So make sure it's in degree mode. So again, you have two ways. You can either use the table for right now, or you can go through and you can use your calculator. So cosine of 33 is equal to, I'm just going to go to the table just for convenience, 0.8387. Because that's the second column. Okay. So we're going to use these ratios to determine missing sides, at least for today. So for my first triangle, first you have to determine which trig ratio you're going to use. I'm going to write this up here. It's SO, CA, TOA. Okay. So for my angle right here, this is my hypotenuse. I don't know anything about my hypotenuse. I know my x is my opposite side, and this is my adjacent side. So which trig ratio uses your opposite and adjacent? Well, that's going to be tangent. So I'm going to write this. I know that the tangent of 38 is equal to the opposite side over the adjacent. All this is this is a proportion. This is opposite over adjacent equals opposite over adjacent. It's just some weird decimal. Okay, this just tells us if I divide, so when I write, so what happens if I have a right triangle with a 38-degree angle, what do I get if I divide the opposite side by the adjacent side? So there's, again, two ways to do these problems. One of the ways is to look this up on the table, so the tangent of 38. So I go up to the table, go to 38, I go to tangent, which is 0.7813. Okay, so I know already, because the table tells me these are all preset values, that if I divide the opposite side by the adjacent, and just make sure again, it's 0.7813, 0.7813 is equal to x over 12. I multiply each side by 12. And I get x is approximately 0.938 or 9.38 centimeters. And that makes sense in terms of my problem. So that's one way of doing it. I'm not going to do another way with this one. I'm just going to set this one up. So here's my reference angle. The 8 is the opposite, and the x is my hypotenuse. So I look and see which trig ratio I use. Well, SO uses is the ratio of the opposite to hypotenuse. So I'm going to set this up. I'm going to say the sine of 16 is equal to 8 over x. Now this one's a little bit different because we need to get rid of the x in the denominator. And so I'm going to actually, the first thing I'm going to do is I'm going to multiply each side by x. Actually, I'm going to back up from there. I'm actually going to find the sine of 16 first. Sorry. So I find the sine of 16, so I go to 16 in my table. It's the first column, 0.2756. So I replace the sine of 16 by 0.2756. Yeah. 0.2756 is equal to 8 over x. Okay, to solve this, I multiply each side by x, so this ends up being 0.02756 is equal to just plain old x is equal to plain old 8. Then I divide 0.02756, and I divide each side by 0.2756, and I get x is equal to 29.03. And I'm going to say round to the nearest hundredth. So that's one way of doing it. You can use the table. You're carrying those decimals. Another way to do it, which I'll show in a minute. So I have my angle here. This is my hypotenuse. This is my adjacent. So adjacent and hypotenuse is cosine. So I say the cosine of 55 is equal to adjacent over hypotenuse. Now I'm going to show you something different. You can actually put all of this in the calculator. So I'm going to multiply each side by 18. You just have to be careful with it. And so x is going to be equal to 18 times the cosine of 55. And you can put all of that in your calculator. Just make sure that you put the 18 first. Okay, so it's going to be 18 times the cosine of 55, and I get 10.32. And don't forget your units. Okay, and of course skip around the video if you don't feel like you need it. Next three. Ooh. Okay, and then we just have some word problems. Here's my angle. This is my adjacent, this is my opposite, so that's going to be TOA. So the tangent of 62 is equal to 24 over x. I multiply each side by x. That's x times the tangent of 62 is equal to 24. And then I divide each side by the tangent of 62. And I have x is equal to, and you can just put that in your calculator, you 24 divided by the tangent of 62. Just make sure that your calculator is in the right mode. So it's going to be 12.76 centimeters. My next one, here's my angle. This is my adjacent. This is my hypotenuse. I'm going to be using cosine. So the cosine of 33 is equal to 6 over x. Same thing. I get rid of x on each side. That's going to be x times the cosine of 33 is equal to 6. Divide by the cosine of 33, divide by the cosine of 33. And you're more than welcome to take a shortcut. I always go through the solving process because students tend to mess it up. 6 divided by the cosine of 33 is 7.15. And the last one, this is my opposite, this is my hypotenuse. So I'm going to use sine, this is so. Okay, and you can refer to it back. So the sine of 28 is equal to x over 21. This is one of those easy ones. Multiply each side by 21. 21 times the sine of 28. And so x is approximately 9.86 centimeters. So those aren't so bad. Next one, a 15-foot feet ladder leans against a wall at 52 degrees. How far from the wall is the foot of the ladder? So again, this is a lot like the Pythagorean theorem problems. We're going to kind of set it up. You just have to be able to see the triangle. So we have our ladder, which is 15 feet. It says it leans against a wall at 52 degrees. So it sounds like that's 52 degrees. How far from the wall is the foot of the ladder? And so we're trying to find this right here. Okay, so here's my reference angle. This is my opposite. This is my hypotenuse. So that's going to be so. So the sine of 52 is equal to x over 15. Multiply each side by 15. And so x is going to be, and it says to the nearest foot, 15 times the sine of 52 is going to be 11.8. Or 11.8. So I have 11.8, but it says to the nearest foot, so my actual answer is going to be 12 feet, because that would be to the nearest foot. Okay, next one, we have the sun's rays strike the ground at 55 degrees. What is the height of a tree? Okay, 21 meters from the base of a tree. Okay, so 21 meters from the base of a tree. What is the height of the tree to the nearest meter? Okay, and so essentially this is the shadow. All right, so here's my angle. This is the opposite. This is the adjacent. And so we're going to use tangent. That's going to be TOA. The tangent of 55 is equal to opposite over adjacent. I multiply each side by 21. It's going to be 21 times the tangent of 55. So 29. So I have x is approximately 29.9911. So x is going to be approximately 30 meters. All right, last one, a little bit more challenging. It says point P is an island found on a lake. To find the distance from P to a point on the shore on the lake, a convenient baseline ABC was taken along the shore, and the following measurements were made. So this is kind of interesting. You can actually measure angles. That's what surveyors do. So you can make these right triangle relationships. So essentially you have two right triangles. You have this one here, and you have this one here, the outside one. Now, the inside one, okay, I actually do have what I need in order to find the missing sides and angles, because I have a side and I have an angle, and that's all you need in order to use trig, an angle other than the 90-degree angle. So it says find PC, okay, so that's the first one, so I need to find PC. And the other one I need to find is PA. Okay, so I'm going to start with PC because it's part of this little triangle right here. Here's my reference angle. PC is the opposite. This is the adjacent. So I'm going to say the tangent of 70 is equal to PC over 150. I multiply each side by 150. So 150 times the tangent of 70, and that's going to be 412. So I get 412.1216, okay, is approximately PC. All right. It says to the nearest yard, so I know that PC is going to be equal to 412 yards, okay. So I'm going to keep that here, but I still am going to use this number because I want to be precise. And if you use a rounded version, you're not going to be as precise. So now I know that this part is about 412. Well, that's actually going to be super helpful because before I didn't have enough information to solve for parts of this bigger triangle, but now I do have a side, I do have an angle, and I'm just trying to find this side right here. Okay, now here is my opposite, and this is my hypotenuse. Try and write that. Okay, so here is my hypotenuse. This is my opposite. I don't know if that helped at all. Okay, and so I know I'm going to use sine. So I'm going to say the sine of 50 is equal to PC over AP. The sine of 50, well, I know PC is around 412.1216. I actually still have the whole number in my calculator. Over AP, I multiply each side by AP. Okay, and so I have AP times the sine of 50 is equal to that 412.1216. I divide by the sine of 50. I divide by the sine of 50. AP is going to be equal to, and I actually have the number, the whole number 412.1216 that keeps going in my calculator. I just take that number and I divide by the sine of 50. And so I get a more precise answer though. So that's going to be 537.98655. Okay. And so I write my answer here, the distance from